Alright, I'm going to run you through how to calculate how much stormwater runoff you get for a site. And so our example here is we have a 4-acre lot of farmland here behind the high school. We want to build a 30,000 square foot parking lot on that farmland to accommodate for when they have events at the football field behind the high school. And our design requirements are for a 100-year 60-minute storm, and so we have to accommodate how much stormwater runoff is going to happen for a 100-year 60-minute storm. And so what we mean by that is if we put this 30,000 square foot parking lot on that 4 acres of farmland, asphalt has a runoff coefficient that is higher than just the dirt or grass. And so with just the dirt and grass there, the water is going to absorb into the soil more than if it was the asphalt parking lot where the water will need somewhere to drain. And so the city is concerned that if we have the 30,000 square foot parking lot, how much of an impact is that going to add to our storm sewer system, where the water collects in the curbs and goes down and is output into Sand Creek. And so we're going to try to figure out how much more water runoff we're going to have by adding that 30,000 square foot parking lot. So the first thing we're going to calculate is the pre-development. So before we put anything on that land, how much water runoff does just the land create? And so if we look at our calculation formula sheet here, we have stormwater runoff. Here we have a formula for peak stormwater runoff rate, and it's in cubic feet per second. And so we'll go ahead and write down our formula. Peak water runoff rate is equal to the runoff coefficient adjustment factor times the runoff coefficient times the rainfall intensity times the drainage area, and in this case that's going to be in acres. And so we'll go ahead and start to fill in our formula. We have A, we know that. We have a 4-acre lot, and so I'll put a 4 in there for that variable. Rainfall intensity we need to look at, and so I'll go out here on the internet and I have input data for Newton, Kansas. So I've looked up on this website. You can see the precipitation rates, and so we have a 100-year duration here, every 100 years. So there's a 1% chance that would happen this year, and we need a 60-minute storm, and so that gives us a rainfall amount of 3.43 inches of rain per hour. The next thing that we need to put in our formula is our runoff coefficient. And so we're going to calculate for C over here. And so runoff coefficient, if we look at our formula sheet, we have the rational method for runoff coefficient. If we look at farmland, farmland is between 0.05 and 0.3. And so we're going to take an average of those two numbers to get a better estimate for our runoff coefficient for our farmland. And so we're going to say C is equal to 0.05 plus 0.3, and we're going to divide that by 2 to get an average of those two numbers. and we get a runoff coefficient of 0.175. So I'll input that into our formula. The last thing we need is a runoff coefficient adjustment factor. And our formula sheet tells us that if we're planning for a 100-year storm, we'd use a runoff coefficient adjustment factor of 1.25. And so I'll multiply all these numbers. 1.25 times 0.175 times 3.43 times 4. And I get a...
Liliana Martinez, please come to the office. Liliana Martinez, please come to the office.
A runoff of 3, about 3, we'll say about 3 cubic feet per second. So if you can think of a box, if it was 1 foot by 1 foot by 1 foot big, every second we're going to have to account for that much runoff water. All right. So next we'll go ahead and do a post-development calculation. So this is after the parking lot has been built. So basically we're seeing how much impact we are having on stormwater runoff by adding that 30,000 square foot parking lot. And so we're going to, first thing we need to do is convert square feet to acres. And so we have a 30,000 square foot parking lot. The conversion factor is 1 acre. We'll look on our formula sheet, is equal to, if I flip and look at my conversions, it tells us that 1 acre is equal to 43,560 square feet. So we'll divide 30,000 divided by 43,560, and we get a parking lot acreage of 0.689 acres. All right. Once we have that, we can figure out the difference. And so if our parking lot is 0.69 acres, how many acres of farmland are left? And so I'll take our 2 acres that we had in our lot. We'll subtract it from the 0.689 acres that our parking lot is going to take up. So I'll take 2 minus 0.689, and I get 1.311 acres of farmland left. All right? And so the next thing we need to figure out again is our coefficient of runoff. And so this time C is going to be equal to our first acreage for the parking lot, 0.689 times the times the rational method for runoff coefficient for asphalt. And so we're going to multiply the amount times the runoff coefficient factor. And so again, I'm going to get an average for these two numbers. So I'll type 0.7 plus 0.95 divided by 2, and I get 0.825. So I'll put that in there for my runoff coefficient. I'll add that to the amount of farmland we have left, 1.311 acres, and the runoff coefficient for farmland is, again, the same thing it was before, 0.05 to 0.3, so we'll average those two numbers and we'll get 0.175, and which that makes sense. So we can see that the dirt is going to absorb more water than the asphalt. We'll divide that whole thing by 4 to get our composite coefficient that we are going to use. So it's 0.689 times 0.825 plus 1.311 acres of farmland left times 0.175, and we're going to divide that number by 4, and we get a new runoff coefficient of 0.199. And so that's our new C value, or our runoff coefficient value. And so the last thing we have to do is just input the numbers back into our formula. So we'll write our formula again. The peak storm water runoff rate is equal to the runoff coefficient adjustment factor times the runoff coefficient times the intensity of the rainfall times the drainage area. And so input our numbers. Our runoff coefficient adjustment factor stays the same, 1.25. We have our new runoff coefficient that we just calculated. It is 0.199. We have the same rainfall. We're accounting for 3.43 inches of rain per hour. And we have the same acreage of 4. And so we'll calculate that. 4 times 3.43 times let's start over. 4 times 3.43 times 0.199 times 1.25. Something went wrong. Let's do that again. 1.25 times 0.199 times 3.43 times 4. There we go, and we get a runoff of 3.4 cubic feet per second. And so adding that parking lot to the lot is adding another 0.4 cubic feet per second of water to our storm sewer system.